Hey everyone, and welcome. Today we're tackling Leetcode problem 2257, count unguarded cells in the grid. This is a really nice grid problem that's all about simulating vision or movement. We'll break it down step by step. Okay, so let's get the main idea. We're given the dimensions of a grid, a list of guard positions, and a list of wall positions. Our goal is to figure out how many empty cells are left completely unseen by any guard. So it's a two-part question. First, which cells are guarded? And second, out of the ones that aren't guarded, how many are also not occupied by a wall or another guard? That's the number we need to return. Now, how does a guard's vision work? Think of it like a laser beam. From their position, they shoot a beam north, south, east, and west. The beam travels in a straight line, covering every cell it passes over, until it hits something. That something can be a wall, another guard, or just the edge of the grid. Let's walk through the example from the problem description. We have a 4x6 grid. On the slide, I've laid out the guard and wall positions. To make this easier to solve, let's imagine a grid where we can keep track of everything. First, we'll place all our pieces on the board. The G's are guards, and the W's are walls. Everything else is just an empty, unguarded cell for now. Okay, let's start with the guard in the top left corner. If it looks east, it immediately sees the wall right next to it, so its vision stops. If it looks south, it sees down until it hits the other guard at row 1, column 1. So its line of sight is blocked there too. If we do this for every single guard, we can start marking which cells are guarded. In the diagram, the red cells are all the spots that at least one guard can see. Notice how a guard's vision can be blocked by another guard, like the one at the top left, or by a wall, like the guard in the middle row. After we've traced the vision for all the guards, we're left with this final picture. The red cells are guarded, the white cells are occupied by guards or walls. The only cells that are both unoccupied and unguarded are the green ones. If we count them up, we get 7, and that's our answer. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. So how can we code this? The most straightforward way is a simulation. We'll create our own grid in memory, maybe a 2D array. We can use numbers to represent the state of each cell. For example, 0 for empty, 1 for a wall or guard, and maybe 2 for a guarded cell. Then, for every guard in our input list, we'll trace its vision in all 4 directions and update the state of the cells in our grid from 0 to 2. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first, and don't worry after that, we'll walk through the most important sections together. Alright, here's the Python code for our simulation approach. It might look a little long, but the logic is very repetitive and straightforward. Let's break it down piece by piece. Start by creating an m by n grid, initializing every cell to 0, which represents an empty, unguarded space. Then, we loop through the guard and wall positions. For each of these, we place a 2 in our grid. We use the same number for both, because, from a vision perspective, they both act as obstacles. This is the core of the algorithm. We loop through our guards list again. For each guard at row R and column C, we run 4 separate loops, 1 for each direction. Let's look at the right or east direction. We start from the column right next to the guard, and go all the way to the edge of the grid. In each step, we check the cell. If it's an obstacle, at 2, we break the loop, because the vision is blocked. Otherwise, we mark the cell with a 1, meaning it's now guarded. We do this exact same thing for the other 3 directions. After the main simulation loops are done, our grid contains all the information we need. We just do a final pass over the entire grid. We're looking for any cell that still has the value 0. A 0 means it was never marked as an obstacle and was never seen by a guard. We increment our counter for each 0 we find, and that final count is our answer. So how efficient is this? For time complexity, the tightest bound is a bit tricky, but we can think of it this way. Each cell in the grid is visited a constant number of times. It's visited once during initialization, and then potentially once from a guard to its north, south, east, and west. So the total work is proportional to the number of cells, which gives us a time complexity of big O of m times n. For space, it's simpler. We create a helper grid of the same dimensions, so that's big O of m times n space. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. Next up, Here is the C++ version of the solution. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. So, let's wrap it up. The big takeaway here is how effective a simple simulation can be for grid problems. By creating a helper grid to manage the state of each cell, we could systematically apply the rules of the problem. Treating both guards and walls as the same kind of obstacle was a small but useful trick to simplify our code. Alright, before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now while it's all free are yours to keep and use forever. So, it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.